Okay, now welcome. We're going to be continuing on with our discussion of some of the technical thinking behind a lean transformation, and again into the technical tools section. We're focusing this time on the tools to improve, which is the skills aspect from the technical perspective of what goes into affecting a lean transformation. So we've covered some tools in the previous section. The tools that we'll be covering kind of on the back half of this, the more higher level stuff, is continuous flow, which is just in time, which is sometimes a little bit more prominent of a moniker. And then we'll also be taking a look at pull system in the next section. So for this one, we'll be focusing on just in time. And really what just in time is, kind of at the core essence of it, is it's the thought process where we want to produce and deliver only, not more, not less, but only what is needed at the exact moment it's needed and in the exact quantity that it's needed. And when we can do that, that's really the most effective way that we can meet our exact customer demand in terms of the product that we're producing, the timing of how we're going about doing it, and the volume that we're actually producing at any given moment. And so there's a couple components to just-in-time. There's takt time, which we've talked about previously, this idea of continuous flow, which we're going to be getting into, and then the last one there, the real high-level stuff, is this idea of pull systems. And so in continuous flow, really the core features of what continuous flow is, the thinking behind it, is that we want to produce in smaller lot sizes. And ideally it would be one by one production, right? So the smallest possible lot size is 1 unit at a time. And where that's not possible, though, we want to work to minimize our lot sizes. And then we also want to sequence our production. So it's not just big batch. We want to get away from batch building with sequenced production, small lot sizes, and then the ultimate goal, then again with ideal thinking, is that idea of one by one production. And so the key point out of this is that it ties back to the kind of the overarching goal of just in time is we want to produce what we want when we need it and in the quantity that we need it. And continuous flow is one of the key tools that can help us go about realizing those goals. And so to kind of draw an example out of it, to get into this, we'll lay out a sample production line. This one's got 3 production processes, and we'll ship our product at the end. And so with traditional thinking, this batch building idea, we have each operator that'll build inventory kind of at their own pace, right? Nothing is coupled together. Everyone is just building to inventory. The next process draws from that inventory, and the process kind of repeats. And then at the end, just like before, we'll have an inspection process to make sure everything looks okay before we ship it out to our customer. Now, what we want to do with lean thinking in terms of continuous flow is we want to eliminate all of those inventory storehouses, and we want to eliminate that inspection process, and we want to link each production step directly to the next one down the line. And what that does is it gives us a couple big, huge benefits. The first one is we're reducing inventory. And inventory is waste because it's sunk money into sunk cost that we can't really get back. The second thing that comes out of that is we want to reduce our lead time. And kind of the way that jumps off in this particular layout is if the second step there has to wait for the first step to build all of his product and put it all into inventory before he can take it. If we can eliminate that, and as soon as 1 unit is done, he can take it and start working, we're reducing our lead time. The last thing, too, we talked about with building in quality. And building in quality, the model we used is based off continuous flow. So we can improve our communication, and we can build better quality. And then what comes out of that, one of the key things is we can reduce our scrap and our waste that way. And so to kind of further hit on the lead time reduction, because that's one of the big benefits out of modeling our processes in terms of continuous flow. So we'll lay out just a sample diagram here with traditional thinking. And what this really represents is the cycle time across the top is just successive minutes. We've got our 3 processes there. And what that's showing is that the first process batch builds all their material. Then we take it over to the second step. They batch build all their material. Then we take it over to the third step, and then they finish what they've got to do with it. Now when we take a step back and look at what that production timeline looks like, well, now the lead time, it takes 27 minutes to finish all of these units. A has to build everything, then B has to build everything, then C has to build everything, right? So 27 total minutes. The other big thing that comes out of that is look at how long it takes to just get the first part from when we start at the very beginning. It takes 19 minutes for step C to finish that first part. That's a long time. With lean thinking, what we want to do with continuous flow, I think the first thing that pops out is look how much shorter that time scale is. Now we've linked A to B to C. So as soon as one unit is done in A, it goes to B. As soon as B finishes, it goes to C. So when you look at the production there, see how it's all kind of overlapped because it's linked and one by one by one? And the thing that should jump out at you is now the lead time to finish. We still built the same amount of units, but by getting away from batch building, the lead time went from 27 minutes down to just 10. That's almost, it's 1/3 of the amount of time to build the same amount of product. At the same time, it only takes 3 minutes now to get our first good part from when we start production versus 19 minutes. That's almost an order of magnitude less. That's the real benefit in lead time reduction with continuous flow, and that's why we want to get away from batch building. The other thing continuous flow lets us do is it gives us a lot of production flexibility. And so with traditional thinking, again going back to that model, we kind of have all of our individual processes in their own little silos, where they have their raw material, they do their work, they build it to inventory, then we ship it to the next stop, they do their work, they build it to inventory, and then we ship it to the next stop, etc., etc. What we want to do with lean thinking is we want to get rid of all those silos. We want to put everything right together and one by one connect all the dots. And what that really does in terms of giving us production flexibility is now in this example, say our customer demand drops and we no longer need 3 processes to do it. Remember takt time and standardized work, being able to figure out how many people we actually need to build what we're trying to do. We'll say something changes and now, or we have a Kaizen event and we figure out a better way to do it so it doesn't take as long. So now we don't need that many people on the line. Well, with continuous flow, now it's easy to drop one person out. We don't have to change our silos and our material handling and change our inventory levels. We can drop one person out. Similarly, if demand goes way up, we can drop one person in. It's very flexible. It's very easy to make changes to the line in real time, to be flexible to our changes in customer demand. But what really comes out of this, and this is always what happens whenever we start talking about continuous flow and getting rid of inventory and tearing down silos and assembling, a cohesive production line. The first one is, if we have downtime in one process now because we don't have all this inventory safety stock, we're going to shut the whole line down. And that's true. That will happen. But what we do is we want to use the skills that we've talked about, stability, problem solving, and Jidoka, to minimize that downtime. And this is why with this program we kind of go through things in a certain order because everything kind of builds upon itself. We start with philosophy so we kind of understand what we're doing. Then we get into management because we have to be able to manage these kind of high-level tools. Because if we can't manage them, the team members are going to struggle, and that's not fair to everybody. At the same time, we can't jump right into continuous flow if we don't have stable processes, if we don't have good problem solving, and we don't have, some of the ideas of Jidoka put in place so that we can see a problem when it happens. Because if those things aren't in place, and we just jumped right to continuous flow, jumped right to the end of the line, we would have our first problem, the line would shut down. It's frustrating for everybody, and that's why a lot of times these lean initiatives fail, because we don't go about it in the right order, and we don't make sure we have a good foundation for success built before we really try and get into the serious stuff. So looking at continuous flow design, kind of the major abstraction, the big things, is that we want to connect all of our processes with the same takt time. We don't want everyone in their silo where it takes one person an hour to do something and the next person 2.5 hours and the third person 10 minutes. We want every process to have the same takt time to produce at the same rate so that we can set that pace of production equal. Then we want the processes laid out in order of operation, steps 1 through whatever, right? So it's a sequence. That's when we talk about sequence. And then we want to strive for one-by-one production within that area. So the 2 examples up there, one is a U-shaped work cell and one is just a linear production line. But what you see is when we take the raw material, it goes from one step to the next step to the next step to the next step, one at a time, until the finished part comes off at the end. There's no interruption. All these processes take the same amount of time to complete, and we're not building up inventory at each individual step along the process, right? One by one by one by one. It allows us to take advantage of building in quality. It cuts our lead time way back, and it cuts our inventory way back. That's what we're after with this. So to kind of highlight the benefits of this, just to kind of put it all in a nutshell, the main one is that it reduces lead time. Huge, huge, huge. If we're struggling with that, we can go back and look at the diagram that I showed earlier, where when we batch build, in that example, it took almost half an hour to finish. And when we did it with continuous flow one by one, we were able to cut our lead time down to 10 minutes. That is remarkable, and that's what happens when we can apply this in the real world. The other things that we get out of it is we're minimizing our inventory, right? We're cutting out all those silos and those big inventory buildups like we did. Now it also kind of forces us to bring our problems to the surface, because we know if we should be building one at a time and each step should be taking the same amount of time, we can see very quickly when we start accruing inventory somewhere we shouldn't be, or if someone is falling ahead, or if someone is overproducing, because we've created an expectation of what should be happening. The next thing there in terms of building up defects goes back to building in quality. This idea of one-by-one production and checking quality at each step means that we're not creating huge piles of inventory where someone could have made a mistake on 1,000 parts, right? We're going to catch that mistake immediately and be able to fix it immediately and save us all the time and hassle of having to now dig through our inventory and do QC inspections. And then the last one there, I don't necessarily think can be understated. It's a little bit vague in terms of some of the context for what we were discussing, but this flexibility for manpower, where that really becomes beneficial is when we start talking about Kaizen. And remember, we talked in the tack time discussion, we kind of reorganize everything, and then there's maybe a little bit left over of time, and we want to try and Kaizen to get rid of it so we have nice, even, full work processes. Well, say, like I said, we find a better way to do something, and now all of a sudden we find out that instead of needing 3 or 4 or 5 people, we just need 2 or maybe 3. Well, when we have the line set up for continuous flow, now it's very easy to restructure those work processes to pull a person out and redistribute the work among 2 processes instead of 3 or 4. And that's why we want to be able to set it up this way, because it gives us flexibility when demand changes or we make improvements in how long it takes us to build things. We can capitalize on that. We're not locked into a certain number of production steps. And so kind of, thinking beyond that, in terms of, what else is required to do this, what should jump out at everybody when we're talking about flexibility for manpower and saying, well, if 3 people used to do 3 separate jobs, and now we've made it easier to do the job so it only takes 2 people, well, those 2 people need to know how to do the work that the third person used to do, right? To be able to complete that task. So we got to be able to develop cross-functional team members. Our people need to be cross-trained. It's easy to say, difficult to do, but the value in doing it in terms of what it allows us to do with Kaizen, once all of our team members understand what's going on and can participate at a much higher level, is well worth the effort to do that type of cross-training program. So that covers continuous flow really in a nutshell. I think the key takeaways from it are focusing on reducing our batch size and kind of getting out of each one of our production steps being on its own little island in a silo. The key thing out of it is that it really reduces lead time and it really reduces inventory. But to do it and to take advantage of it, we have to be able to problem solve, we have to be able to manage abnormalities, and we have to have good stability in our process, or the whole thing will break down. So we need to make sure we've built up some competency in the earlier skills before we really try and take advantage of this and cut our lead times by half or a third. So, as always, any questions, shoot them through the website, and we will see everyone for the next section. Thank you.